Most students see this question and immediately panic because look at this monster. Nested adjoints, determinants, powers. Looks like somebody wrapped a matrix inside another matrix, like an onion. So naturally, students start expanding everything. Big mistake. Here's the trick toppers used. Matrix inside, determinant outside. That one idea destroys the whole question. Before we start peeling this onion, we need just two killer properties, and the third one is a bonus. If K is a scalar and A is an n cross n matrix, then determinant of Ka is equal to K to the power n into determinant of A, and adjoint of A is equals to determinant of A to the power n minus 1. The second property, probably the most important one for this question. And once these two properties are in your pocket, this scary looking onion starts peeling itself. Let's dive into the core of this problem. Look at the very center. We have adjoint of 2A. Now think sharp. We know these properties, especially property number 2, which says determinant of adjoint of M is equal to square of the determinant of matrix M for a 3 cross 3 matrix. So here in place of M we have 2A. So determinant of the adjoint 2A is actually square of determinant of 2A. But wait, we need to pull that constant 2 out of the determinant. So when a constant comes out of a 3 cross 3 determinant, look at point number 1. It takes the power of the order. So 2 comes out as 2 cubed multiplied by determinant of A. Because the whole thing is squared, we get this, which simplifies to this. Keep this result in your pocket. We will need it in a second. Moving one layer out, we are multiplying A squared now. Now the beauty of the determinant is that they are separatist, meaning the determinant of the product is the product of the determinant. So we can split this into this. Now we know determinant of A square is square of the determinant A, and we already have the value of determinant of adjoint, which we have substituted in it, and we got this. Now combining these two terms, our inner core is now this. Now we need to move to the next layer by including 3 adjoint of this. Now similarly, if we have to pull this 3 out of this determinant, we are going to use property 1. So it's going to come out with the power which is equal to the order of this matrix. That is equal to 3 to the power 3, and determinant of this adjoint is, using this property, square of determinant of this inner part. Now we have already found the value of this part, so we will substitute that in. So we get this, and squaring it, that means we get this. We are almost there. The very last step is the outermost adjoint. So taking the entire determinant, we have this. Now adjoint of this entire thing is equal to determinant of this entire thing to the power 2. Now we have found out the determinant of this entire thing just above. So we'll substitute that in. So we get this whole square. Let's distribute this outer square. So we get this. Now we know determinant of A is equal to 6. It's given in the problem. So let's put that in, and 6 can be factorized as 2 into 3. So we'll get 2 to the power 16 into 3 to the power 16. So simplifying which, we will get this. So this monster thing has reduced to this, which means 3 to the power 22 into 2 to the power 40 is equal to 2 to the power m dot 3 to the power n. So comparing both sides, we have m equals to 40 and n is equal to 22. Now the problem asks for m plus n. So m plus n is 40 plus 22, which is equal to 62. This is how you peel the onion without crying over the calculations. No massive multiplication, just clean property work. And there you have it, the adjoint onion completely peeled. Most students see a problem like this and think it's about heavy calculation, but as we just saw, it's actually about pattern recognition and staying disciplined with your properties. If you managed to get 62 before I did, drop a sharp in the comments below. If you got stuck on one of those power traps, that's exactly why we are doing this series. See you in the next trap.